session, we would like to take you through processes of actually solving a task when it is given, or even looking at the performance task, just a sample performance task. What it is, you will some simple questions or sample questions, as well as the strategies that you can use. So we've been looking at the 3 reads strategy. That is one that we'll be using to explore our performance task today. And we want to review a sample performance task at the grade 5 level. Please note that the sample performance task that is being done here is not the one that you will be getting in the exam. So kindly bear that in mind. Now, the 3 reads strategy. Now, what is this strategy all about? We are encouraging you that this is one strategy along with the other strategies that your teacher would have taught you that you can use. But this is a very powerful strategy. Now, in this strategy, it helps you to actually look at a math problem close up, look at it in detail and in parts. But this strategy involved is that you actually read the task, the scenario, the question, whatever it is, 3 times with a different goal in the mind each time. And so for the first read, it's for you to really understand the context. And then for the second read, for you to understand the mathematics. What math is involved? What operation do I need to use? What strategy, what method can I use to solve the problem? And the third read is for you to actually ask yourself some questions about the scenario. All right? Let's look a little deeper. So again, for the 3 reads, the first thing you should be saying to yourself is, what is this task about? And then when you've found that out, you want to know the question that you're asked to answer. What is it that they want you to find out or to do? And finally, you want to look at the important information that is given so that you can now answer the question that you are asked. All right? So that's the 3 reads, and we're going to be using it as much as possible in today's presentation. But guess what? It's all your performance task is all about problem solving, making decisions, and so on. And so I think it's fitting for us to now just inform you a little about a 4-step approach in problem solving. The first thing you need to do when you're given a problem is to understand the problem. And that's why the 3 reads is very, very important. Now, after you read the problem, you understand the context, the scenario that is given, and even the question you need to answer. You now need to devise a plan, come up with a strategy, come up with a method as to how you're going to solve. And then you just carry out that plan. That's the 3rd step. And the 4th and final step is to ensure that you look back or check over your work to ensure that what you have done is correct. And even if you think it's correct, you must go back over it. And so it's time for us to look at a sample performance task. Remember, we're asking you to participate. You're going to do this or indicate to us that you want to share by using the raise hand feature. We will ask you to unmute your microphone, and we're asking you to do so quickly and ensure that your background is quiet so that persons can hear you when you talk. So let's get ready to move right ahead. So here's our performance task for today. It's about a fundraiser. It says, you are an executive member of your school's math club. One of your responsibilities is to raise a fund for the 2025 project. The club wants to raise $60,000 to upgrade the school's math room. They decided on a fun day, and I'm sure we all love fun day. And that's one way to raise funds. Now, your performance task, as you can see here, part A, will have at least 3 parts, some 4 parts, depending on the scenario that is given and what they will ask you to do. And so we want you to now look at part A. And part A is not to be done in isolation from parts B and C and D if you have a 4th part in your performance task. They are all linked, and I want you to know that from this. So part A here, and let me go back. Remember, let's look back. It says you are an executive member of your school's math club. One of your responsibilities is to raise funds for the 2025 project. The club wants to raise $60,000 to upgrade the school's math room. They decided on a fun day. So that's our second read. And I want you to do a third read. And by now, it's very clear what this performance task is about. All right. So again, we're doing a fundraiser. So type in the chat right away what the performance task is about and what it is that you need to do. While you're doing that, let's move on to part A. Part A says revenue from entrance fee. The entrance fee to the fun day is $250 per person. The committee wants to raise a quarter of the target from the entrance fee. And then it says, calculate the revenue that must be made from the entrance fee. Again, that's a question, but we must look at the question and the information given at close-up view. The entrance fee to the fun day is $250 per person. The committee wants to make a quarter of the target from the entrance fee. You're asked to calculate the revenue that must be made from the entrance fee. Now, based on that, let's just engage me a little here. What information was given that we can actually use? If you'd like to share, you can raise your hand. Or you can go ahead and type in the chat. All right, so somebody has typed that we need to raise funds to upgrade the math room. That could have been from the previous question that was asked. And all right, so Annika said we need to we need to find out how much is to be raised, all right? Or she said the amount to be raised is given. What's the amount to be raised? All right, so St. Richard's, you can go ahead and tell us what information is given here. St. Richard's Primary.
Good morning, Miss.
Good morning.
I think what you're supposed to do, since it's saying that since they're saying that they want to raise 60,000 and you want quarter of it, and quarter of 60,000, 15,000, you should find what 250 times what gives you. And
all right. So let me before you get to that part of the question, you did point out the amount that they want to raise, which is 1/4. That's one of the information that's given. And we also know that the entrance fee is $250,000. We will need to find a quarter. So we'll take that information from you. And I think you're muted just now. Let's continue. So those are two things that are very important. Each person must pay $250 for entrance fee, and a quarter of 60,000 must be made from the entrance fee. So let's look at bullet 2. A quarter of $60,000 that must be raised from the entrance fee. What are we going to do to get the answer? All right, so we see some late responses in the chat that we need to, information given is that we have $60,000. The target is $60,000 and we need a quarter of it. Thank you. So go ahead now and tell us. Let me give you about 30 seconds to work it out. Awesome. So we're seeing from Padmore saying that we need to divide 60,000 by 4. And from Nelson that we need to find a quarter. So go right ahead and find a quarter of 60,000. Erisa, you want to look at your response there. All right. So already the answers are coming in the chat, but let me give a couple more persons just a couple more seconds to write or to type your answer in the chat. Go right ahead. All right, so the answers are coming in slowly. So remember, you are also to work the question in your notebook. That's the reason for asking you to come with your materials. Awesome. So as I look at the answers coming in the chat, I think you are ready because they're coming in fast and furious now. So here we go. How much money or how much revenue must be made from the entrance fee? We know that we need a quarter of $60,000. It should be a quarter of it. And what is that? Like some person says, find a quarter of $60,000. And if you notice in the cloud, we have 1/4 of $60,000, but to the right of it, we now have a quarter and the word of has been replaced by a multiplication sign. And the 60,000 is now written as a fraction with 1 as the denominator. And how we go about doing this? We find a factor that can divide exactly into 4 and 60,000. And 4, of course, can go into itself 1 and into 60,000, 15,000 times, all right? And so our answer will now be 1 times the numerator multiplied by the numerator, 1 times 15,000. And don't forget to put in your $sign. I want to make sure that we emphasize this because I saw in the chat a number of answers coming in without the $sign. So children, we're encouraging you to make sure whatever the unit is, you use it in your answers. Very important. The persons who mark your paper, they look for things like those so that you're not giving all numbers when you should just be giving money and, all of that. So pay attention to that. So we are putting it out there based on our calculation that $15,000 must be made from the entrance fee. I want to encourage you, children, that this information will be needed sometime. When you're doing your performance task, remember I said the parts are connected. So another question might ask for this bit of information for you to actually solve it correctly. So let's move on. Part B talks about fun day attractions. The table shows the attractions available at the fun day and the cost for each. Boys and girls, we want to say to you when information like this is given that you are to pay keen attention to it. Don't just glance over it and rush to go and answer the question. So the first attraction is the go-kart at a cost of $500 and then the bounce about for $100. That would be per ticket and per ride. And then we have the water slide offered for $200 and beautiful face painting for $250. So that's very important for you to note. And if anybody wants to make a note of it in your book, go right ahead and do so. Now, for the fun day attractions, there are some conditions to use the attractions. This is what it says. Each child can ride the go-kart once, only once. They can enjoy any number of other attractions as they can afford. And each child can and must take part in at least 2 attractions. I wonder if anybody wants to just tell me what that means. What do you understand from the third bullet? If you raise your hand, then of course we are ready to take your response. What does it mean by each child must take part in at least 2 attractions? All right, so Excelsior, go right ahead. Excelsior Primary. Excelsior Primary, you're asked to unmute at this time. All right, moving.
There.
Okay, go ahead.
Excuse me, miss. It means that the kids should miss it.
Remember, your background must be quiet, so go
Excuse me,
ahead.
miss. It
Yes,
means that a kid's supposed to do in part of two attractions.
in part, what does that mean? When you say a kid must do
Take
in
part. Take
must
part.
take part, thank you, must take part in,
Two attractions.
is it only 2 attractions? Can they take part in more than 2?
Yes, miss.
All right. So what's the minimum of minimum attractions they can take part in?
4.
Minimum? Like, what does minimum means? So minimum there, okay, minimum means the least amount. So what's the least amount of attractions that they can take part in?
They can take part in 3, miss.
The least amount. So that's something we want you to understand. When you see these words in bold, they
Least-
are there. What's the least amount they can take part in? Let's give someone else a chance.
There are
So-
some answers in the chat, Mrs. Williams.
Oh, go ahead, Miss
There are
Harris.
several answers in the chat. I think I saw from, was it Padmore? Padmore mentioned that you must go on 2 or more attractions.
Okay, that's a beautiful way to put it.
2 or more. And someone responded to your minimum question and put 2 attractions. So we got
Awesome.
an answer, 2 attractions or more. That's the
Thank
most
you so
explicit one
much.
that I've found so far. Great.
Beautiful. Thank you so much, Miss Harris. And it's very important, children, that we understand when we see these words in bold, what they actually mean. And also, as we say, you do your 3 reads, making sure that you understand the context as well as the mathematics. So when it says bullet 1, the child can ride the go-kart only once. It means that just one time. They cannot take that attraction, go on that attraction more than once. All right? And then you are hearing that you can enjoy any number of attractions. That would have been a giveaway. And point 3 or bullet 3 says at least 2 attractions. 2 or more attractions, or no less than 2 attractions. Thank you for that. So let's continue. It's very important that we understand the context. Now, here we go. The prices are shown on the table, which you saw earlier also. Look at this. It says, a child has only $1,000 to spend on the attractions and want to spend as much as possible. Again, it's in bold. And so it's telling you something. The child wants to spend as much as possible. All right? Type in the chat what you think that means. A child wants to spend as much as possible. And we're seeing some raised hand there. Anything as yet in the chat? The child wants to spend as much as possible. And we're not going to stay a long time on this. All right, so let's move on. All right, I should spend lots of money. I'm not in agreement with that one. Not in agreement with that one. All right. All right, so we'll go over that quickly. It means that you can spend the maximum of what is given there. Remember, you have to bear in mind how much money you have. So this child has $1,000 and wants to spend as much on the attractions given. Here we have 1,000. The child can spend only, cannot spend above 1,000. You can spend under, but the child wants to use up as much of the $1,000 as possible. All right, so we have to put that disclaimer out there. Now, part B says, list 3 different possible combinations of attractions that they can enjoy. So we're going to give you some time to look at the attractions on the screen and see 3 different combinations of attraction that the child can enjoy. So, first of all, possible combinations. I wonder what we mean by combinations of attraction. So let me just quickly go through that as you are working, because I see answers coming in already. 3 possible combinations of attractions. What can you combine? Or what rides or attractions you can now combine or put together that will help you to spend that $1,000 or as much of that $1,000 as is possible. All right. So I see persons are working. You must remember that the child has $1,000, only $1,000 to spend. So while you're doing that, I like what Kaylee Abrahams put in the chat. She put here go-kart and she put the cost with it, as well as bounce about, the cost with it, and water slide and the cost, but I did not see your total. So that's very important. Excelsior, you have put the attractions, but we don't know what you're going to do with the attractions. Are you going, yes, show us how you're going to know that that is sufficient to reach the expected amount, which is $1,000, or as much of it as is possible. So while you're doing that, we thought that a strategy such as using a table to put that information on would be very good. And so, children, you want to organize your working in such a way that whoever is marking your paper understand clearly what is given. So one strategy that you could use is to display your information in a table. Remember, as I said, from Excel, say the child put the name of the attraction plus the other attraction. So the name of the attraction, the cost of the attraction, and being added to the others, which is very good. But here is a table that you can actually use. So before I reveal any of my combination here, I want to hear from somebody. What is your combination? Let me give at least 2 persons a chance to share. If you raise your hand, we will identify you. James Whittingham. Say your school and go ahead. James Whittingham, you're asked to unmute.
My 3 combinations are go-karts, bounce about 3 times, and water slide. then go-kart, bounce
Okay.
about 5
Can
times,
you hold a minute,
and
James?
water slide 4 times. Water
Thank you,
slide,
James. James?
water slide 4 times, and face painting.
Thank you, James. You just reel off all of them and we didn't get a chance to. Actually, give me your first one, James. You said
I
go-kart
said
and
water slide 3 times and face painting.
water slides 3 times. Let's see if that can work. Go-kart, what's the cost for the go-kart? So we have go-kart at a cost of $500 here, and water slide 2 times, 3 times rather. That's 3 sets of $200. That's $600 plus $500. That gives me 1,100. So James, go back to the drawing board. If you do a question like that, and we're looking at our problem solving plan that we have, there's something that you need to do. So James, look back at that, check over your answer and make the adjustment. And that's why it's very important for you to check over your answer. All right, we're going to take from another person your response. And I'm so happy for James's response because we could now look back at our 4-step in our problem solving. You would have used the information given. You came up with a plan. As you came up with a plan, you worked it. However, there was one thing, the final step, which is to check over that you needed to do. All right, let's give Michelle Gordon. Michelle Gordon, go ahead. Share only one of your combination. Go ahead, Michelle. Right ahead, Michelle. All right, we're not hearing from Michelle. So we'll take Kimarley. Kimarley Sims. Kimarley Sims, go ahead. And children, when you open your mic, just start speaking. Kimarley?
Yes.
Go ahead,
Miss.
Kimarley.
My school is St. George's Girls Primary Infant School, and my
Yeah.
3 combinations are go-kart, bounce boat, and water slide.
So go-kart only once, bounce about, and water slide. And there, for Kimarley, we have go-kart being $500, bounce about $100, and water slide $200. The thing is, that would be, I noticed you said your 3 combinations. However, we want you to get it clear that when it talks about 3 possible combination, it must be 3 different sets. So if is this the first one? Yes. If it's the second one, you're taking something different from what you would have stated. So let's look at that. We're going to reveal also. And then from this, we want you to be following with the second and the third combination. So if a child chooses go-kart, you look at the amount of time, and this is number of tickets showing 1. So there we have it, number of tickets once. You want to put in that information very clear. The calculation means here we have 1 times $500, meaning the child is going on the ride only once. And so you just need 1 set of $500, which gives you the total of $500. Then the next ride to go in this combination is the water slide. This child has decided to go on the water slide just once. And so the calculation there is 1 times $200. So far, the child has spent $700 and can go on other rides. So let's look how this child has now decided to do 1 face painting, which is $250. And it's very important, children, that you show how you know that this combination is good. So this child has chosen a combination of 3 rides. So it's good for you to put in the total. It's a cost of $950. All right. So that's one combination. This is a second combination. Somebody who has not yet spoken, would you like to, and you would like to go ahead? We're going to St. Peter Claver. So St. Peter Claver, could you share a different, all right, I lost them there. Let's go to New Day. New Day primary. New Day, share your second combination. So that's New Day primary.
It's a go-kart. It's one go-kart, one
Yes.
boat, and two water slides.
Awesome. So let's look at that. One go-kart, which is $500. New Day, close up already. Close your mic already, New Day. Two water slides, $400. So that's $900 so far, and a bounce about. Excellent. Excellent. So while you're choosing your attractions, you must be looking at the cost. Thank you so much for that. So let's look at that second one that we came up with. Bounce about. You can go on the bounce about 3 times, but you must do your calculation, which is 3 times $100, give you 300. And this person wants to go on 2 water slides. That's 2 times $200. So the unit cost there, $200 for one ride. So if it's 2 rides, it's going to be $200 multiplied by 2 to give us $400. And finally, this child has chosen face painting. And how much is this? That's another $950. And I have seen several responses in the chat. And of course, this is another possible combination. All right, go-kart, $500. Water slide, one time, this is one times $200, and 3 sets of bounce about, which now maximize the $1,000. So there we have it. So remember, we had conditions for the ride. You can go on any amount of rides you want to go on, or any amount of the attractions. You can use a go-kart only once, and that the child has $1,000 to spend. And so you work that $1,000 as best as possible. I want to put it clear out there that after you would have done one combination, a second combination, and a third combination, that's what your answer requires. So not just 3 rides you're putting together, but you're doing 3 different combinations. So it's good for you to label them to say combination 1, combination 2, combination 3, showing what 3 ways in which, or 3 different ways in which the child could use up the $1,000. We went ahead and did a 4th one. So here we go. We're just going through them as quickly as possible. And here we have it. Bounce about, 1 time. Water slide, 2 times. Face painting, 2 times. And the calculation, we have it there. And we have a total of $1,000. And the final combination, we're doing one where this child just decided to go on 2 attractions. But let's look at it. The child is going on the bounce about 2 times. So that's 2 times $100. That's $200. And this child loves the water slide. So this child goes on the water slide 4 times. And there we have it. 4 sets of $200, $800, and this child has maximized their 1,000. We went ahead and did 5 just to show you that different combinations can work, but you were only asked to do 3, and you could have done any 3 of these combinations. All right, so we want you to get that. Thank you so much. Now look at this question.
Yes, Hazel.
Go ahead, Miss Harris.
Good morning.
I'm so sorry, I lost her there. So revenue from the funding. Look at this question. The table below shows the tickets sold for each attraction. Copy and complete the table and calculate the revenue from the attractions. We're giving you some time to copy this table in your book, calculate the revenue from the attractions, get the grand total, and then share. We're giving you about 1.5 minutes. So again, the table below shows a ticket sold for each attraction. Copy and complete the table and calculate the revenue from the attractions. 1.5 minutes to get it done quickly and be ready to share.
If you're talking, Mrs. Williams, we can't hear you. Your mic is muted if you're speaking.
So our 1.5 minutes is finished and you're ready to share. So we're going to see, we're going to hear from St. Richard's Primary. Please unmute and be very clear with your speaking. Make sure your background is quiet. Go ahead, St. Richard's.
Okay, so for the go-kart, it would be $15,000.
All right.
For the bounce about, it would be $7,000.
Tell us how you got that.
For the water,
Tell us how you got your 7,000 for the bounce about.
70 times 100.
Awesome. Go ahead. For water slide now.
For water slide, it would be 40 times 200, which is equal to $8,000.
Excellent.
For the face paint, it would be 50 times 250, which would equal to $12,500.
Okay.
Okay, the grand.
Go ahead.
Okay, and the grand total would be $42,500.
Thank you so much, St. Richard's, for sharing, and that's clear as crystal. So let's see. You said 70 times 100 is 7,000. Awesome. And then you said for the water slide, why? Okay, so we have 40 times $200. So again, remember we said the information given, you need to pay close attention to it because at some point in time, you need to go back to it. We have put beside this table and beside this question, the attractions and the cost. And so it's easy for you to relate to it, but you might not have it like this in your performance task. And so you would have to go back to the table that was given previously. And you did so very well. So face paint cost $250. And so this would now be 50 times $250, giving us a total of $12,500. And for the grand total, you add everything, which gives you $42,500. Awesome. Thank you so much. And by now we all understand. I saw some persons put the answer in the chat, but I want to say to the schools here, Excelsior, and there's another one, HD. I'm not sure about the HD, can't recall which one that is. Say that again, Paul's Delight. I love what you have placed here because I can address you. Please remember to put your $sign. Please remember to put your $sign. Mr. Leamy, someone is asking if there's a link for YouTube. If so, could you put that in the chat, please? Thank you. All right, so the link, if there's anyone having difficulty joining us on the platform, you can actually join us on YouTube. The link has been placed in the chat. Thanks for asking that question. And by the way, it's not too late for you to call up a friend from another school and remind them to join if you don't see them here. So thank you so much, St. Richard's, for sharing that. Let's move on to the next question. The next question, here we have a heading says, revenue from the fun day. 80 students attended the fun day. Calculate the revenue from the fun day.
The presentation.
So here we go. 80 students attended the fun day. Calculate the revenue from the entrance fee. How are we going to do that? I don't have anything here for you. I wonder if anybody is ready to share. How are we going to do this? If you're ready to share, we want to take from as many schools as possible. All right, let's hear from Kristen Gray. We have heard from Hall's Delight. Let's hear from Kristen Gray. Kristen, go ahead. Go ahead, Kristen. How are we going to find out the total revenue?
18 students attended one day, and each of them paid $250 to get in. In all, it would be $20,000 from the entry fee.
Tell us how you got your $20,000. Kristen? All right, so Kristen muted before she could answer the question. Notice that Kristen said that each student would pay $250 for their entrance fee, which is very important. And so to get the total, she didn't tell me, but she has come up with the correct answer. So the information needed here is that each student pays $250. Very important. And again, this is coming from the very beginning of the scenario that was given. And so we are showing you how connected even the very first information is throughout the performance task. And to get that, we now would multiply the 250 by 80 and get $20,000. Now, based on your answer to part A, or to question A, in part A, did the club meet their target? And you are to justify. So I'm waiting to hear from some others. All right, so let's take Carleen Gordon. Carleen Gordon, please share if they have met their target and justify. And that, Carleen? Go ahead, Carleen. All right, no more calling. Let's move over to Excelsior Primary. Have they met their target? Excelsior. All right, not hearing from them either. Final call. Go ahead. Go ahead.
I'm from Excelsior Primary and Idfab School.
Okay, great. Go ahead. Have they met their target?
Yes, miss.
Justify your answer, meaning to explain why you're saying yes. Do you know the target that they are working towards?
Good morning. It's Excelsior Primary.
What's the target that they are working towards? All right, so we need to get them to organize who will speak there. So teachers, have them organize who will speak. All right, I think we have been on this one for quite a while, but I really need to hear from you. I don't want to reveal the answer. So let's move on.
Did you hear from Michelle Gordon or Carlene Gordon? You could probably take from one of them. Carlene had her hand up and she also typed in the chat that there are 2,500 left off the dollar sign though over their target. That's what Carlene Gordon said, that there are $2,500 over their target.
All right, so, thank you so much.
Only thing she left off her dollar sign, but that was, she's made the point that they've moved their, she's past the target at this point.
Thanks. So here we are having it not only from myself, but from another coach. Children, remember to use your unit or your the symbol for the unit that you're working with. Very important. Go ahead, Carlene.
Go ahead, darling. Okay, the attraction was?
Mr. Attraction was the attraction was 42,500. And the entry fee was 20,000. And they made 62,500.
All right, so remember, don't move, stay right there. How much is it that they needed to get from the entrance fee? That was given earlier. So you have gone over to the attraction. We're not looking at the attraction, we're looking at the entrance fee based on what what the question here. It says here, 80 students attended the fun day, calculate the revenue from the entrance fee. Now, based on this here, and then it says revenue from the entrance fee, this is based on your answer to A in part A. It means you have to go back to part A, which they had asked. They had given you some information about a quarter of the money needs to come from the entrance fee. A quarter of the revenue needs to come from the entrance fee. And we worked that out as a quarter of $60,000, which was $15,000. So that was their target from the entrance fee. Very, very important that we don't mix that up. So that's the bit of information. Now, why am I emphasizing this and placing so much time on this? Again, to remind you that your performance task, the different parts are linked, meaning that a question that is coming in part 2 or part B, part C, might require you to go back to an earlier question that was done to use the information from there to actually answer the question. So here we have it, that $15,000 must be made from the entrance fee, and according to the revenue from the entrance fee shown here of $20,000, we can agree that they have made their target, or they have met their target. So the revenue, which is $20,000, is actually greater than the target of $15,000. So yes, they have done so. Thank you so much. Now, another question relating to the revenue from the funding. It says, what was the total revenue from the funding? Go right ahead and get ready. So let me give you a minute to work on this. What was the total revenue from the funding? And then I'll give you a chance to open your microphone and speak with me how you arrive at the answer. All right, so some persons are already ready to share. Let's hear from Mannings Hill Primary. Tell us how you arrive at the answer. Mannings Hill Primary. Go ahead, Mannings Hill. Unmute. Mannings Hill Primary, go ahead and unmute. All right, we're going to move on. Okay, go ahead.
The total revenue, the total revenue from the attractions and the entrance fee was $62,500.
You want to explain to us how you got that? It's very important. Tell us.
How I got my answer
Yes.
was I added up the total amount of the attractions and the total amount of the entrance fee.
Excellent. Thank you so much for sharing. And that's very clear. And children, we're asking you to do this because we want you to be very clear when you're writing your answer for any question, whether it's for an external exam or even in your own school or for your own exam. So the information needed, as Mannings Hill told us, is revenue from the entrance fee and the revenue from the attractions. And we want to see your clear working. So information written nicely, what it is that you're using and what it is that you're doing, the operation addition to give us the answer. Because your answer alone might just be 1 mark, but putting all those details there will give you the full mark for the question. Thanks for that. Now, based on your answer in E above, did the math club reach their target? And it's time to justify your answer based on your answer to E above. Did the math club reach their target? Let's hear from Taylor Henry. Taylor Henry. Go ahead, unmute and share with us.
Miss, their goal was $60,000 and they got in total 62,500. So they passed their goal. They got their goal and they passed the goal by 2,500.
Thank you so much, Taylor Henry. Can I tell you something, children? When you see a question like this and they ask you to justify it, that's how you are really to go about explaining your answer. Make mention of what the target was. Make mention of what they made. And of course, say how much they have gone over. That's very, very important. It shows that you're using information from your task to actually justify your answer or to explain the reason for your answer. So there we have it. The target is $60,000. The math club, of course, they made 62,500. So a justifiable answer is, or a justification for this is, the math club more than met their target since the total revenue was 62,500, which is 2,500 more than the 60,000. And you could put it any way you want to put it. We're just saying to you, make mention of the target given and the amount made and say why it is the target was met, or if it wasn't met in another case. All right, let's move on. All right, I think we are up for part C. I will be taking just taking a break from this section, and Miss Harris will come on in and take you through the rest of the presentation. You have been participating so well so far, and so we ask that you continue. Miss Harris, over to you. Please unmute, Miss Harris.
I'm not unmuted yet. I open my video. All right, let's go. Good morning, grade 5 students eager to go. Before I go into my portion of the presentation, teachers, I'm asking you to please just type the name of your school, the number of students present. If there's more than one class, you can name the class, or just state the class and the number of students present. But we need to have that for records, please. So please have the school and the number of students present from your school. And if it's several classes, each class and the number of students present from the class. Thank you very much for that. Thank you, Mrs. Williams. And I'm really happy at the engagement as so far. And just want to point out that purpose of the chat is not for nonsense. I'm seeing 1 or 2 persons. I think it's Rupindra or something like that, typing some gibberish in the chat. Please stop that. It's not for that purpose. So we will move right on. We're now at part C. So we've looked at the fact that they've made their money. And now we're looking, remember that they're trying to upgrade the math room. So we're now going into the section where they're going to upgrade the math room. So are we ready? So the club wants a blackboard on a section of one of the walls in the math room. And they've given us some criteria, some conditions for the blackboard. The blackboard must be a rectangle with dimensions that are whole numbers measured in meters. One of the following areas should be the rectangle. The rectangle should have an area of one of these numbers, 8 square meters, 9 square meters, 10 square meters, or 12 square meters. And finally, the blackboard must be a rectangle with a decorative border strip, with decorative border strips along its border. So you need your notebooks going on forward from here because we're going to be working together, but you also need to be doing your calculation as well. So choose any of the areas, whether it be 8 square meters, 9 square meters, 10 square meters, or 12 square meters. Okay, so I'm going to choose the first one. And the area that I'm choosing here is going to be 9 square meters. So for 9 square meters, remember, it must be a rectangle. The length of the sides must be a whole number. And I'm going to be putting a border around it. Okay. So we've chosen an area of 9. You could have chosen 8. You might have chosen 10 or 12, whichever one you choose. I'm choosing 9 for this one. All right. So let's go into our discussion around it. Based on what they said for us, pardon me, we need to have, you're going to create 2 rectangles. So from your chosen area, we've chosen 9. You're going to have 2 rectangles, and each row must have the dimensions for rectangle that matches your area. So we're choosing 2 rectangles, and they must each have an area of 9 square meters. Could I have some persons typing the chat quickly? Well, I'm happy that, thank you for your feedback, teachers, for the students, number of students present in the school. So those who have already typed, you could probably just quickly type in the chat for me. What could be possible length and width if the area chosen is 9 square meters? Let me see a couple responses quickly in the chat, and then we move forward. All right. I'm still seeing the names. Let me see if anybody would like to raise their hand and unmute to tell us what they would say is a possible. All right, go ahead, Arisa. What would you suggest as one of the rectangles?
Arisa, we're asking you to unmute. So there are several devices there, and so we're getting a feedback. We will move on from Arisa.
Okay, so could we take from, I think we heard from Manning Seal, so could we take from Sandra Graham Mitchell's class?
That's Sandra, go ahead.
You can unmute Sandra Graham Mitchell. All right, that's taking a while as well. I'm going to scroll down quickly and I'm saying one last time. Edward Siaga, would you like to share your feedback? Could you suggest Possible areas for rectangle with 9 square meters. We're going with the 9 first.
It's
I'm seeing some answers in the chat.
Meter square.
It's 81 meters squared.
81 meters square, but it's supposed to be 9 square meters. So read the question carefully. We want the area of the rectangle to be 9 square meters. And you're going to suggest to me a length and a width that would give us an area of 9 square meters. So make sure we're clear on what the question is asking. All right, I'm not hearing Sandra's person. Go again one last time, Sandra Graham Mitchell's class. All right, I'm seeing some answers in the chat. 4.5 by 2. 4.5 meters by 2 meters. Remember, they must be whole numbers. So we can't take the 4.5 by 2. We cannot take 4.5 meters by 2 meters because they must be whole numbers. So I'm seeing length of 4.5 and a width of 4.5. Watch for those numbers. Remember, we want the area to be 9. I'm also seeing a length of 5 and a width of 4. Wanted to look at that as well. Would that give me an area of 9? So be careful as you choose your, what we call the dimensions, the lengths and the widths. So I'm going to just share with you what are the rectangles that we came up with. We came up with 2 rectangles. One will have a length of 9 meters and a width of 1 meter. Now, how would we calculate the perimeter for this one? Before I show you, suppose it had a length of 9 and a width of 1. Quickly type in the chat. So what would be the perimeter of that rectangle? Length of 9, good. I see Janoya had her 1 by 9. One says it has to be 9 by 1. I'm not so sure. It has to be 9. One of them is 9 by 1, but it doesn't have to be 9 by 1. Good, I'm seeing another one here. So what would be perimeter if it's 9 by 1? Beautiful. I missed these in the chat. Several came up in the chat with a 9 by 1, and I'm also seeing a 3 by 3. Great. So if it's 9 by 1, what would the perimeter be?
So
20.
Jay,
Remember the units.
I
20
see
meters.
yes,
Good.
Jace Brooks. All right.
Where is-
So go ahead, Miss Harris. I'm just pointing out some of the answers in the chat. So we're seeing 20 meters.
Right, for the perimeter. How did
Perimeter.
we get that 20? Could I say a little bit of the addition or whatever you did to get that 20? Let's see some addition of that, how we got that 20. All right. So I'm going to share 20 meters square. Woo, 20 meters square for the perimeter. Let's look at that again. Remember, perimeter is a length unit. Good, I'm seeing. Are you seeing any additions there coming up, Mrs. Williams?
Yes, I'm seeing how's the light. They put there so beautifully. 9 plus 9 plus 1 plus 1 equals
I'm seeing
20
that too.
meters. Beautiful.
Vincent, I see you have a 9 plus 1 times 2. Remember to put your 9 plus 1 in brackets. So if you're going to put the 9 plus 1 times 2, make sure to put the 9 plus 1 in brackets.
And finally, one final one, Padmore. Primary has 9 plus 1 plus 9 plus 1 equals 20 meters.
Beautiful,
and you know,
thank you.
Even though I said one last one, I love what Ken Barnes has put here. Ken Barnes' class. Perimeter, the word perimeter is there equal 9 meters plus 9 meters plus 1 meter plus 1 meter equals 20 meters. That's the one I am very much impressed with.
And did you see Kara Dawson's class? She has perimeter equals 2 times length plus 2 times width. And then they put out their 2 times 9 plus 2 times 1 equals
Excellent.
18 plus 2. Beautiful work here by Kara Dawson's students. Beautiful. Thank you. Thank you for all the feedback. Beautiful. Well done. Remember our units. Remember our units. So we'll continue. So to calculate our perimeter, just as you've said, the perimeter would be 2 times 9 plus 1. Or you could have said 2 times 9 plus 2 times 1. However you presented it, that's fine. Giving us a perimeter of 20. A few of you also gave us the other possible dimensions of 3 meters by 3 meters. And of course, our perimeter there. Would the perimeter be different? I wonder if it would be different. Let's see. What would I have as my perimeter this time? My perimeter this time would be 2 times the sum of the length and width, which would be 3 plus 3, giving me a perimeter of, what's that going to give us here this time? 12, isn't it? 12 meters. And I did see a few persons putting in that 3 by 3 as a possible rectangle earlier on, not many, but I did see a 3 by 3. Let me point out again, I saw several, not several, 1 or 2 persons saying the rectangle could have been 4.5 by 2. 4.5 by 2. Can somebody tell me, just type in the chat, why I couldn't take 4.5 times 2? Just type in the chat quickly, why I couldn't take 4.5 times 2. Or if there's a raised hand, let me take it. Why couldn't I take 4.5 times 2? You want no decimal? Okay. Because it has to be a whole number. Thank you, Padmore. Victoria Campbell, you're almost there. You want no decimal is fine, but they had said explicitly it must be whole numbers.
All right, Miss Harris. I am scrolling through the chat and the praise tab has a question for you. With the 3 by 3 dimension, the question is, wouldn't that make it a square?
Oh, wow. Wouldn't be a square, all right. It's a square. So what's your question, praise tab? Is it that it's, tell me, are you saying that it's a square, but does it mean that it's not a rectangle? Is that what you're saying, that it's not a rectangle? If that's what you're saying, let us just look at that quickly. How do you recognize a rectangle? What are the things that make a rectangle a rectangle? Let's look at that together. Remember, for a quadrilateral to be a rectangle, it must have opposite sides parallel to each other, and that pair of opposite sides must also be equal in length. So if I have my rectangle, just quickly draw a rectangle for me, please, on screen, Mrs. Williams. Just quickly draw a rectangle for me, please, on screen, and let us look at it together. If I have a rectangle, the length of the top, length of bottom, let's say length of top and bottom, if we want to put it like that, top side, top length, and bottom length, those would be parallel, correct? Those lengths have to be equal. Fine. Is that true for a square? Top and bottom equal? It sure is. It also says both pairs of parallel sides must be opposite to each other. The pair of sides must be parallel to each other and equal in length. What about these, the left and right for the square? Are those equal? Yes. So it just happens that the top and the bottom, as well as the left and the right, are equal in length, but they satisfy the criteria for a rectangle. Well, 2 of the main ones. There are other ones related to the diagonals, but we're looking at the lengths of sides now. Top and bottom, it may not be at this way up. Suppose the rectangle was slanted. Opposite sides are parallel and equal. Sides that face each other are parallel and equal. So once the sides that face each other are parallel to each other and equal to each other, it makes it a rectangle. Is that clear for praise tab? Let me see a thumbs up or a question mark if you're clear.
May I chime in, Ms. Harris?
Please, Mrs. Mundell Thomas.
Yes. So you made mention of the sides, but also important for it to be a rectangle is the angles on the inside.
On the corner. On the
right. They must be 90 degrees.
Correct. So they must be right angles. I didn't mention that part, and that's important. Thank you, Mrs. Mundell Thomas. So Mona Prep is making the point that all squares are also rectangles, and we were just discussing why the square is also a rectangle. It has 4 right angles, just like the rectangle, and the opposite sides are parallel to each other and equal in length. Are we all clear on that? So I hope everyone is clear on that. That is a common, it's not uncommon to hear that question. So I'm glad it came up in this session so that anyone who wasn't clear on it is clear on it now. But that's a square with equal sides. So how? All right, gonna try it one more time and then we move on. Remember, every rectangle has 4 right angles, correct? So all the angles are 90 degrees. That's one thing for rectangle. All angles are 90 degrees. But also for rectangle, opposite sides must be parallel to each other and equal to each other. What do we mean by opposite? It's either left and right, top and bottom, but whatever it is, the sides that face each other must be parallel to each other and equal in length. So we won't separate angles and rectangles because that we don't want to feed that misconception. If you separate squares and rectangles, it suggests that they are different, and we don't want that suggestion to be perpetuated. We want for students to appreciate that a square is a rectangle. So in this case, we have a possible rectangle happens to be a square because all its sides are equal, but opposite sides parallel to each other and equal to each other. As Mrs. Williams shared on the screen, the side measuring 1 faces the side measuring 1. They're both parallel to each other and they are equal in length. So I trust I'm seeing many yeses. So we purposely did this just to continue to reinforce the important concept that you don't need to separate squares from rectangles. Okay, so we won't say identify a square or identify a rectangle. If you have identified a square, you've identified a rectangle. The square is just what we could call a subset of rectangles. The quadrilaterals have many interlocking relationships. So I hope we're all clear on that. I hope Mrs. Williams, this diagram assisted you with that. Praise Tab and others, I believe you said you're okay. But I thank you for your suggestion, Miss, from Excelsior. However, we're hoping that the whole thing is clearer. We don't want to separate the two, but we want to be clear that a square is also a rectangle. Beautiful. So let's move on, Mrs. Williams, to our continuing. Remember, we want to have 2 possible rectangles, and one of the rectangles happens to be a square. All right,
Okay.
so now let's consider if we had a 12 square meter area for the wall. You're welcome, Praise Tab, a pleasure. So we could have Manning's Hill Primary suggesting a 3 by 4 could be one of the 12. 3 by 4 is one, another person is saying 2 by 6. So we could have 3 by 4 or 2 by 6. Beautiful. So if we have 6 by 2, 6 meters by 2 meters, then we're going to have a perimeter of 16. Is that correct? 2 times 8 giving me 16, correct? So I'd have a perimeter of 16. And if I had a 3 by 4, I would have a perimeter of, let's see. All right, another person has a 1 by 12. So I could have had 1 by 12. Excellent. I could have 1 by 12, 3 by 4, 6 by 2. Any of those would be fine. Mr. Limi, I would like, if possible, to prevent Ripindra from typing in the chat. He or she insists on being disruptive. So could we just please prevent him from putting in, him or her from putting in the chat, typing in the chat.
What's the name?
Ripindra, Ripindra.
Okay.
All right, so let's move on. So if we had, then I'm going to type in the chat already how we would have calculated the perimeter for the 4 meter by 3 meter. Good, we have 3
We're
by
seeing some
4.
responses here. Some persons have put in the answer as 14 meters.
14
And some
meters,
persons
beautiful.
are really, really on the ball. They are not just giving the answer, but they are showing how they work it out. So for example, halfway tree primary, they have 2 open bracket, 4 plus 3 close bracket equal 14 meters. Excellent way of writing your answer. And there's Natalia Barnes, St. George's Girls.
Let's look at that one. Let me see that.
That one, she has 2 open bracket, 4 plus 4 close bracket, and 2 open bracket, 3 plus 3.
Okay, I would love to
But
hear
the
some more
answer was
about
not
that one.
written. The answer was not written to complete it
Is
to
it
say,
saying 2 times 8 minus 2 times 6? Could you retype that for me? I'm not sure if I'm following that so well at St. George's Girls.
Exactly. So look at that minus 2 there again.
And why you have the 2 on the outside of the brackets? Because if you have the 4 plus 4, that is already doubling it. So if you have 2 times 4 plus 4, you're actually having that 4 times. So let's retype that for me, please, Miss Barnes or Mrs. Barnes class, so we can see where we're at with that. Beautiful.
And
Thank you for the
that we didn't
responses.
go over it, Miss Harris. I'm happy that we did not go over that one because for Barnes there, as you said, the 2 for that one, let's quickly show how this could be written. Once you have the 2 outside, it means that you're multiplying anything in the bracket by 2. So it would be 2 times 4, as would have been shown here, plus the 3 that's given, which is now 7, multiplied by 2, giving you a perimeter of 14 meters. All right. So we could just write that in just for saving time. And then that was the 14 meters. All right. And you can always put your meters here on the outside to be consistent. So again, 2 open bracket, put the length and the width, 4 plus 3, add those, and then multiply by 2, which this would definitely give us 7 here. So 2 times 7. All right.
Mrs. Williams, I don't want to, I'm seeing another person having that 2 times 4 plus 4 minus 2 times 3 plus 3. Could you quickly just work that out for me and let us see what's the difference?
Which one is?
This would be
Can you just tell me what they have?
So they have 2 open bracket, no, not an octagon, that's 4. Yes, octagon. So it would be 2 4 times 4 plus 4 in brackets.
Okay, and we wanted them to see why, when you put 4 plus 4 in bracket, what happens. And then close bracket, and then what?
And then they have take away.
Yes.
2 open bracket, 3 plus 3. The same thing that, what was that person earlier again? Was it Aliana?
Don't remember the name, but
yeah, but I'm seeing the same thing here. So there might be more than one person. So let's work that out together. What would
4
that
plus
2
4
times
in the
4
bracket?
Yes, that's it. So that part would give us 2 times 8. Thank you, miss. Minus 2 times 6, correct?
Right.
So I'm going to have 16.
2 times 6 here is 12. And for space, I'm just going to put it above. So that's 12. And we must keep our minus sign, right? And then, of course, the 2 times 8 here is 16. So this is what we have. And we keep our operation right through. So we have 16 minus 12. 16 minus 12, which would now give us an answer of 4, which is right beside it already, but I'll write the answer because it's totally different, of 4 meters. So go ahead, Miss Harris.
So we want to be clear, and interestingly, I see another person with So we want to be clear, Pembroke Hall, I see you doing something similar, where you have the 2, open bracket 3 plus 3, and I guess you mean a plus sign 2, open bracket 4 plus 4. We have to be careful with our use of brackets. Remember, well, you haven't done order of operations yet, if my memory serves right. You're either gonna, remember the rectangle only has 4 sides, you know. So if you have 2 times 3 plus 3, it means that I have 2 sets of 3 plus 3. That would mean I have, that represents all of 4 sides with length 3. That's what that would mean. And that's not the shape we're dealing with. We're dealing with a rectangle. So we have to be careful of how we model or how we represent this calculation. So even if you're going to use your 2, as Mrs. Williams pointed out, it has to be 2, open bracket 4 plus 3. So you're multiplying the sum of the length and width, which is a 4 plus 3, by 2.
And that's what you have here, Miss Harris.
Which is what
So
we
you
have
can
there.
pay
Okay.
attention to that.
So just wanted to point out that I think wherever we have that, let's clear up that error, please. So you can't have the bracket. I don't know if you're saying, I don't know, but just clarify that, please. So let's move on. So those are the possible ones that we have. Now we said using 1 unit length on the grid to represent 1 meter on the wall, we wanted to draw 2 different rectangles. We don't know if you got to bring your grid paper, but let's say if you don't have grid paper, just represent your rectangles on the paper, showing the dimensions, okay? So let's say you don't have grid paper, just make sure you draw your rectangle and make sure your rectangle is reasonable. So if you have 9 by 1, make sure the one that is 9 is just about 9 times longer than the side that is 1. All right? And if you're having 3 by 3, let the sides look almost equal to each other if you don't have grid paper. So we're asked to use 1 unit length on the grid to represent 1 meter on the wall. We want to draw the 2 different rectangles rather, and put in the dimensions. So let's just see what those 2, we're going to use our 9. Let's see what those will look like. What would that look like, Mrs. Williams? Let's share that with them. We have the 9 by 1, I believe. So that's 9 by 1.
Do you want me to share the others?
Sure. And then you have the 3 by 3. If we had used the 12 square meter one, we could have had the 3 by 4 and the 6 by 2, I believe we had. And 1 or 2 persons talked about 12 by 1, which would have also had, but we were asked to only do 2 rectangles. So if you had chosen the 12 by 1, you would have drawn your 12 by 1 as well.
Ms. Harris?
What do you notice about the rectangles that have a 1 meter side? Are the perimeters bigger or smaller for the same area? What do you notice? Are the perimeters bigger or smaller? Type that in the chat quickly for me, please. For the same area, what do you notice about the sides that have the shapes that have 1 meter? Are the rectangles, are the perimeters smaller or bigger? Look at your calculation. Do I get a bigger perimeter for the same area, or do I get a smaller perimeter for the same area if I have only 1 meter? Anybody notice anything with it? Okay, I'm seeing Victoria saying that I get a bigger one. The perimeter is bigger for the 9 by 1. Great, thank you for that feedback. We're gonna move on. So I hope everybody gets an idea of what this looks like. And even if you weren't given a grid paper, but you're asked to draw your rectangle, put in your dimensions, put in the measurements for each side, making sure you have your units in place. So ensure you have your units in place. Even if you're not given a grid paper, pardon me, make sure that you draw in your rectangles and they should look reasonable. Okay, let's move on.
Before you move on, Ms. Harris, There's
Sure.
something that I noticed that you would have paid attention to here. This section, this key here that says each square represents 1 square meter. I noticed that. And so as you drew your rectangle, you paid attention to the grid. For the 1 meter, just 1 square that you have taken into consideration going in this way, all right? 1 square, all right? And then for the 9, you counted your 9 squares. So that would be your 1 meter. This is your next 1 meter square going along. And you did 9 of these, which we want the children to pay attention to.
Thank you for that, Miss.
All right, so I could just shade them to show that you would have done the 9 of them.
So if I were to count my, oh, sorry, I spoke over you.
Go ahead, Miss.
So as Miss said, notice that inside of that rectangle, I have 9 squares. In all of them, in both of them rather, I have 9 squares within the border. 9 squares because my area is 9. The region enclosed, the surface inside the border, inside the boundary, adds up to 9 square meters. Similarly, for the 12, I would have 12 squares in all.
Excellent.
Since they said I must have a rectangle, it must be a rectangle. I could have had other shapes, but they said it should be a rectangle. All right, so notice that the 12 square meter one has 12 squares in all. You can literally come up the 4 by 3 and you have the 6 by 2. So inside, because each square represents is 1 square meter, then I should have 12 squares within the boundary for the 12 square meter one and 9 squares within the boundary for the 9 square meter rectangle. Great. Thank you for that reinforcement, Mrs. Williams. So now we're going to, remember, upgrading the room now. So we're going to look at the next part. Border strips are sold in lengths of 1.5 meter at a cost of $200 each. They do not cut strips. They're only selling whole strips. Okay, they're only selling whole strips. Which of the 2 rectangles in question C is better for the club to use? Which of the 2 rectangles in question C for the 9 square meter one? Can I hear from you? Which is better? Which is better to use? And give me the reason for your answer. Let me hear from Edward Siaga, Primary. I see your hand up as a first in line. Which of the 2 rectangles would you choose for the 9 square meter one?
So they have lowered their hand. We could probably
go to their hand. What about grade 5, Campbell? Is your hand still up for this one?
So you're asked to unmute grade 5, Campbell. Go ahead.
Are you showing which of the 2 rectangles you'll use, grade 5, Campbell?
No, Miss, no.
Okay, well, okay, then we'll lower the hand. What about Michelle Gordon's class? Which of the 2 rectangles would you use, and give the reason for your answer?
So Michelle Gordon, we're asking you to unmute. If not, we'll go to St. Richard's Primary. All right, they are ready. Michelle Gordon? Not hearing anything, we'll take St. Richard's Primary. Go ahead.
Good morning. I think we should use 3 by 3 because 1.5 meters is the half of 3 meters. So plus, Miss, if you would use the 9 by 1, Miss, at the one part, you would leave back with this 0.5 meters of the strip.
Okay, so that's that. Thank you for that. Thank you for that. So you're gonna use you said you're gonna use a 3 by 3. All right.
Like her reasoning.
I like that reasoning. It's
Doesn't
interesting.
Want anything left over.
So you don't want you don't want to have to okay. So let me ask something now.
You want to hear from Alexi when you're through?
I see a number of persons are saying the same thing. They'd use a 3 by 3 because it's easier to divide into 1.5. Somebody said that, well, we're not at the 12 yet. It's easier to divide by 1.5, and the 9 by 1 room will be too narrow. Remember, it's not the room, it's a portion of your wall. So it's the 9 by 1 room will be too narrow. I'm not sure why it'll be too narrow, but so why can't I cut off? I get the strip. What's stopping me from cutting off a part? When the 9, can't I get 6 going across with 1.5 and then I cut off the bottom piece? Just asking for a friend.
While you ask and wait for the answer, Miss Harris, Victoria Campbell said the 3 by 3 because it is easier to be divided by 1.5 as well as it is less expensive.
So I wonder why it's less expensive, miss. I'm not sure. What makes it less expensive? I'm seeing people keep telling me why is it less expensive?
Again, I see there New Hope saying that it is cheaper. It is the cheapest to purchase. So I know Miss Harris is asking why is it less expensive? It is a cheaper, or yes, it is cheaper to purchase. So she's asking you all of that because a question like this that asks you to give your reason for the answer. If you remember earlier, we asked you to make mention of certain important information. So if you're saying it is cheaper to purchase, you must have something to refer to. What makes it cheaper? Put that information in your reason or show the working for it and then refer to it to say it is cheaper by so and so or it is cheaper because of so and so. So thanks for inquiring, Miss Harris rather. And let's see if anybody has so we're still seeing more affordable, cheap, small. Okay, New Hope said it has the smallest perimeter.
It has a smaller perimeter, all right. I quite like the insight that it is 1.5, but I would want to point out that the length of 9 also fits the 9, also fits 1.5 because 6 times 1.5 also give me 9. So I could use them going across one, but I would have to cut off a part. It's 1.5 meter strips. So I could use it along one line, one side.
All right.
So I hope we can see that.
Awesome. So we're going to just put it all together now. Go ahead.
We can go on now. All right. I think going forward, Mr. Lee, we could be shut down the chat, please, and then we just take the raise hands because children are getting carried away and writing, typing things in the chat that are not appropriate. All right, so which of the 2 rectangles? We have chosen rectangle 2. Why are we choosing rectangle 2? Remember, your border is going to be linked to your perimeter. And I want to commend the persons who brought out the perimeter because the truth is that's the feature that is going to be most key. I do not in any way discount your idea that it is going to be a factor. 1.5 can go exactly into 3 with no remainder, or I can get 2 sets of 1.5 from 3. So I can see that. So rectangle has a smaller perimeter. So if it has a smaller perimeter, the border, the amount you need to, the number of strips you need to go around the border will be less. That's the key idea that we want to be thinking about. We want to be looking for the border that is less. Because remember, you're going around, we're going along the border rather not necessarily around, we're going along the perimeter, we're going along the border. And so if we're going along the border, we want to be thinking of the perimeter of the space for the blackboard. All right. The last part says determine the minimum number of hole strips that you will need. And we're looking for perimeter of rectangle 2 for the 12-meter one. So the minimum number of strips, if they come in 1.5 lengths, how would we find the minimum number of strips? We want to find how many we will need to go around the 12-meter. because the perimeter for that rectangle, that second rectangle was 2 times 3.3 plus 3, which is 12. So we're looking for the perimeter for 12 and want to see how many 1.5 strips I will need. Go ahead, Michelle Gordon. I see you've raised your hand. How would I find the minimum number of strips that are needed? Have you asked Miss Gordon to unmute already, Mrs. Williams?
Sorry, still searching. Miss Barnes?
Michelle Gordon.
Gordon. All right,
at
Michelle,
the
you
top.
may unmute. Go ahead.
How would I find the minimum number of strips?
1.5 is 12, which would equal 8.
Could you go a little closer to your device? We're hardly hearing you.
Oh, sorry. So 1.5 into 12 would equal 8. You can check your answer by doing it the other way. 8 times 1.5. And since 200 is for each strip of each strip, then you would be 200 times 8, which would give you 1,600.
Okay, you've gone ahead of us though, Miss Gordon, student. Thank you. So we want to find out how many strips, the minimum number of strips for the 12 meters, as you rightly said, would be 12 divided by 1.5, giving us 8.
Okay.
All right. And I like how you said you could check your answer. That's a good strategy to use. Very good. So the perimeter, given the perimeter of the rectangle, the second rectangle, which is a smaller perimeter, and a smaller perimeter would have fewer border strips, making my cost less. So we can move on to show that the number of strips we need would be 8. As you rightly said, I'm going to need 8 border strips. Beautiful. So I'm going to need 8 strips, just as you rightly said. So we found out how many strips we need. You went ahead of me and calculated the cost of the strips, which was our next part of our question. And how much money does the club have left to spend? Let's quickly look at those two things, Mrs. Williams. The cost of the strips would be 8. Remember that each strip costs we need to go back. I think we might have made a change with the cost of the strips without realizing it.
I could go back for you. There we
we
have
had it
it.
as 200, but it should have been 5, but that's fine. It should have been 500 and not 200. So sorry about that. So let's look at
Can
the
we
cost
ask
of
them
our
to do this new calculation? If the strip
Sure.
costs
What's the cost of the
$500?
strip? Each strip costs $500. The cost of the strip for this 12, for the 3 by 3 rectangle. Okay, and we're getting what for that one? 7 participants raised their hand. Go ahead, Amir McLeod. What did you get?
All right, Amir McLeod, please unmute. While he's doing that, other persons were encouraging you to type your answer in the chat.
We had asked her to shut down the chat because children begin to type unnecessary things in it. So unless sir, well, you can reopen it if you think it can work, sir. So because the unmuting does take a little time.
Okay, we could take from Praise Tab. Praise Tab could open their microphone and speak.
Okay, the chat is reopened and persons are putting their $4,000. Praise Tab, go ahead. Quickly. What was the cost for the strips? Remember your dollars, students.
Very good. That's Miss Harris. I'm so happy that you asked Mr. Leamy to reopen the chat because we're actually seeing how students would write their answer. And several persons have entered their answer without the $sign, which is going to cause you to lose marks for your answer. You must use your unit of measure.
And it's also useful to say, if you're going to say what is the cost, do not just write down 4,000. Show that you're multiplying the 8 by 500 to give you your 4,000, okay? So thank you for that feedback, $500 times 8 or 500 times 8, giving us $4,000. Thank you for that. So we can move on, Mrs. Williams.
The next question now, or before we get there, we'll just show them what you just mentioned, the cost of the strip, and then the total.
So after they bought the strips, we've asked how much money does the club have left to spend? All right, so, and how would we know how much money the club has left to spend? What would I need to do to determine that?
We'd love to hear from some persons, Ms. Harris. That's a very important question.
How would I know how much money the club has left? Is Amir's hand still up? All
So
right,
I
so
think
there's
that was an
subtract.
old hand. So
I'm
the
seeing
new
several
hands can be
subtract
raised
in
now.
the chat. All right. You'd have to take away or subtract. All right, great, thank you. So I take away my 4,000 from 62,500, leaving me with what? Let's see the balance quickly, Mrs. Williams, so we can. So I'll have $58,500 left. Great, that's remaining. Let's move on, Mrs. Williams. So the students, remember they're upgrading the room now. They're stepping up, they're leveling up with them boom. So the pictures below show some resources the club would like to buy for the math room. They must buy a printer, 30 gearboards, and one other electronic device. This is what we're working with. Here are the costs. So quickly jot down the costs, please. We don't have a lot of time. We're quickly jotting down the costs. Projector for $17,600. Printer for $19,600. TV, $28,000. Gearboards. We have 2 options for the gearboards. 6 for $3,200 or 10 for $5,000. So we'll have to subtract. Thank you. We've moved on from that we need to find out. That's what we would have done to get the amount of money they have left to buy resources. So quickly drop down these prices, please. Gearboards, $3,200 for 6. Gearboards, $10,000 for 5, 10 for 5,000 rather. Printer, $19,600, and so on. Remember, they must buy a printer. They must buy a printer. They're to buy 30 gearboards and one other electronic device. So those are the conditions. And your performance tasks will typically have some conditions for you to follow that you must be guided by. So you're going to suggest 2 ways you could get the gearboards. Suggest 2 ways you could get the gearboards. Remember, I have gearboards coming either 6 for $3,200. So remember, I'm not just buying gearboards. I want to suggest 2 ways you could get the gearboards. All right, I see someone typing that you could get 5 sets of the 6. I could get 5 sets of the 6. Excellent. That would give me 30 because 5 times 6 is 30. And what's another way I could get the 30 gearboards? I could go 5 times 6. And what else could I do?
I'm seeing 3 sets of 10.
3 sets of 10 from Michelle Guns, right? So Woodford Primary has 10 by 3, 3 sets of 10, or 5 groups of 6. Excellent. Thank you for that. I wouldn't have 15 by 2. Why? Because they didn't sell me any gearboards in pairs or in groups of 15. So look out for that, Janoyas. You can say 15 by 2 because we don't have any gearboards coming in sets of 15 or in pairs. So you have to work with what is available, either 3 sets of 10 or 5 sets of 6. Let's move on, Mrs. Williams. So look out for that. Look out for what is available. Though 15 times 2 does give me 30, I don't have my gearboards coming in sets of 15. So 15 by 2 would not work. All right, so be careful with that. So the 2 ways I could get my gearboards, as you've rightly said, would be using a set of 6. I could get 5 sets of 6. And if I bought 5 sets of 6, it would cost me $16,000. If I bought my 3 sets of 10, it would cost me $15,000. And I see some persons working that out in the chat. Beautiful. We're going ahead. Wonderful. And I'm very pleased with what we're seeing so far. So we've seen the cost of the geoboards. All right. We must buy a printer. So I have to spend that $19,600. So I have my printer. I must buy the printer. So now you're asked to use one of the combinations for the geoboards. Whether you're going to use your 5x6, excuse me, or your 3x10, choose one. We want to calculate the total cost of the resources bought. So you're going to remember that you must buy the printer and one other electronic device. So if tweaking an electronic device to purchase, let's quickly purchase that. So we're almost down to break to end. So let's go quickly.
Are you ready for the reveal, Miss? Or you want to take it? All right, great.
So go ahead. So we have if I bought the 3x10 and I bought the projector and the printer, this is what I would spend. I'd spend $52,200. All right. If I bought the geoboard, the 6x5, then I'd have the printer and the TV, I'd have that as my total. Remember, as we work on all of these, let's look at them carefully. How much money, bear in mind, remember that you have how much to spend, $58,000. So can my cost go above? Obviously not. So which of these would you choose? Oh, we should have given them some numbers. If put a number over each of them for me, please, with numbering from left to right. 1, 2, 3, 4. Let me hear which ones you would choose. Oh, well, we probably don't have time for that. Let's just quickly go to it, Mrs. Okay. Let's just quickly go to it. 1. Can I choose 1? I could use 4. Okay. I could use 4 and I could use 1. Okay. The first one or the fourth one. I could choose the first one or the fourth one. Great. And I can't choose 2 or 3. Why? A lot of you are choosing 4. 4 would be cheaper, but that's all right. What do you notice? Am I able to buy the television? No. So some people are choosing 1, some are choosing 4. So the TV is too expensive. So let's continue. We can go on, Miss. 2 and 3 are more expensive. And not only are they more expensive, 1 is more expensive than 4. We can't choose 2 or 3 because it is out of our budget. Very well said, China. It is above the amount of money we have to spend. We have $58,000, I believe it was, to spend. And these are gone over 58. These are over 60. This is even above the money that they had aimed to raise. Are we clear, everyone? So let's move on, Miss.
So there you have it. The choices
so I
have been
could choose
shown.
1 or 4. And John Mills is saying the same because it's above the amount of money we have to spend. So did the club achieve the goal of the fundraiser? Let's bear in mind, what are the essential things we need to include as you explain your answer? What are the essential things we need to include? A number of you have begun to say it. It's above the amount of money we have left to spend. And what else? That we must buy certain things. All right, so.
Did the club achieve the goal of the fundraiser? Yes. Go ahead and
so the goal of the fundraiser was to upgrade the room. And so did the club achieve the goal of the fundraiser? Yes, they did. They've brought in $62,500. The cost of the resources is $53,200, even if we pick the more expensive one. So whichever one they choose, they are within the budget. And the cost of the strips, of course, is 4,000. So either way, they would have spent either 57,000 or 56,000 for their overall costs. I see Miss Gordon has her hand raised. Did you have a question to raise, Miss Gordon, as we wind down?
So, Miss Gordon? Doesn't seem that way. She's
Okay,
not
so
putting-
let's move on. So we've come to the end. You've seen that they've met their goal, and we want to now ask you to evaluate the session. It was a pleasure just sharing with you today, boys and girls and colleague teachers. So before you go, please, teachers, have the students evaluate for us. Ask maybe 5 or so of your students to give responses